So good afternoon everyone and welcome to this lecture. Brand new day and a brand new topic. And the topic is somewhat a continuation of what we were doing in the previous class. The topic is wave motion. Now, what do you understand by the term wave? First of all, that is the first term that we must understand. What do you mean by wave? What do you mean by that term wave?
So the combination of crust and trough is called as a wave.
Combination of crust and turf is called a wave. Okay, if we just now, whenever a particle moves in space, if you have a particle of mass m, and we have seen that up till now that particles are moving, it has kinetic energy. Whenever a particle moves in space, it carries the kinetic energy together with it. Wherever it goes, the kinetic energy follows. Just like the network. Wherever you go, your network follows. Wherever the particle goes, the kinetic energy goes along with this. Yes or no? You understand this? You don't have to write everything. You just have to understand it. Everything is not worth writing. And remember, no, you are not going to appear for your board exam. This is just to explain what I want to say. This is just to make a introduction. Now, apart from a particle moving through space, a particle actually literally moves through space and it carries energy with itself. Now, there is another way to transfer this energy, with another way to transfer this energy from one place to another without any actual transportation of matter, without any bulk motion. There may not be eventually particles moving from one place to another. If you have to carry energy from one point to other point, you may not simply use particle, give it energy and throw it away. Okay, this is a particle, I have given energy, I'll throw it away. You may not do that. You can do this in a different way without actually transferring the particles. That becomes your wave. So, what is a wave? That gives us a very good introduction of the term wave. What is a wave? So, wave is nothing but a disturbance. Wave is nothing but a disturbance that propagates, moves in space. We don't say move because there is no motion as such. That propagates. So whenever we use the term wave, we will use the term propagate. Wave propagates. Wave does not move. Whenever a wave is a disturbance that propagates in space, and what does it do? That is more important. It transports energy and momentum from one point to another without the transportation of matter. Matter does not get transported. Matter does not get transported. It's only the energy and the momentum that gets transported. Do we understand this? Yes or no? No or yes? So
Yes,
basically,
sir.
now we can understand that there could be two types of motion. There could be, we have done translational, rotational. We're not talking about that translational and rotation. We are talking about, because in the last topic that we are going to discuss today, discuss at the end will be dual nature of matter. Do you understand dual nature of matter? Particle matter may have dual nature. Light has a dual nature. Do you understand the meaning of dual nature?
Yes, sir.
What? What do you mean by dual
Particle
nature?
and wave, particle and wave nature.
Now you can understand the difference between a particle nature and a wave nature. In a particle nature, we consider it to be made up of particles, and particles actually move from one point to another. to other, and when they are moving from one point to other, they are carrying momentum as well as they are carrying energy. Do we understand this?
Yes, sir.
Then there is the other type of motion, and the other type of motion will be known as, if one motion is known as particle motion, the other motion will be known as,
Wave
huh?
motion. Wave
Hmm.
motion.
That will be known as the wave motion. In this wave motion, again, the energy and the momentum would be transferred. The energy and momentum would be transferred, but there will be no transportation of matter. Only energy is transferred. Do we understand this, or this has gone above other saying bye bye? Bye bye, bye bye, sir. I'm going. Ah,
We understood, sir.
Pakka na, sir?
Yes, sir.
Hmm. That is what you call the particle nature or the wave nature. Light has dual nature, and then we will understand even a particle can have a wave nature that is known as the D or de Broglie wavelength. De Broglie wavelength. Do we understand this?
Yes, sir.
Then, as soon as we understand what do you mean by waves, everyone has noted this down? Yes or no? No, yes?
Yes, sir.
Then we have the classification of waves. How are waves classified? We go to it quickly. Waves can be classified according to different ways. The first way of classification of wave is the green one, necessity of a medium, whether a medium is required or not. Whether a medium is required or not. If a medium is required, then it is known as a mechanical wave. Mechanical waves are also known as elastic waves. It is where the medium is required. Then the second type of wave is known as EM wave or non-mechanical wave. They do not require medium to transfer. They can even travel in vacuum. Do you understand this?
Yes, sir.
The second way of classification of wave may be how energy is getting propagated. Progressive wave, where energy is transferred from one part to another. Stationary wave, where energy is not getting transferred, but they are waves. Then you can have other classification as well based on dimension, whether it is a one dimensional, two dimensional, or three dimensional. You will not get much questions on that. The another important is the vibration of particles. Now, if the wave is mechanical wave, then only this thing comes because then only the particles vibrate. Because whenever wave is traveling in a vacuum, particles may not vibrate because there are no particles to vibrate. Now, depending on how the particles are vibrate, if the particles are vibrating perpendicular to the direction of propagation of wave, we will call it transverse wave. If they are propagating in a direction which is along the way, we will call them longitudinal waves. Do we understand this? Yes or no? No or yes?
Yes, sir.
Everyone is noting this down, I hope. Now, Have you noted this down, everyone?
Yes, sir.
Yes, sir.
Okay. Now, no matter whatever type of waves that you are talking about, there are certain characteristics, certain qualities, certain points that is common to all. You can write characteristics of wave motion. Characteristics of wave motion. Now, whatever type of motion is there, whatever type of wave is there, this will be the characteristic. What is the first characteristic of wave motion? Wave is nothing but it is a disturbance. It may be traveling in a medium, then it is a disturbance. It may not be traveling, but again, it is a disturbance, right? Now, medium is only required for which type of wave? Medium is required only for which type of wave?
Mechanical and non-mechanical.
Mechanical medium of some there.
Yes? Medium is required for which type of wave? Medium is required only for mechanical waves. Medium is required only for mechanical wave. I just not told you. What are you writing? Did not write it? You did not write
We
it?
wrote it, sir.
Okay.
We wrote it, sir.
So remember it. Okay. Now, specifically talking about mechanical wave, whenever this wave is traveling through any material medium, the particles will vibrate simple harmonically, and therefore we have done it after simple harmonically motion. They do not leave their position and move with the disturbance. Particle actually do not move. They only vibrate at their own positions. Do we understand this?
Yes, sir.
These simple things are necessary for us to understand the basic nature of wave, and so I am giving them. Now, all these particles which are vibrating simple harmonically, they would be in different phases. There will be a continuous phase difference if we are talking about a progressive wave. If we are talking about a stationary wave, then the condition is different. Talking about traveling wave or progressive wave. Then the velocity of the particle at different position, the velocity of individual particles. Remember, whenever we are talking about the velocity of the particle, we are talking about the velocity of the particles which are in SHM. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now, there are two types of velocity that we will encounter here. One will be the velocity of the particles. There could be infinite particles in the medium. One would be their velocity, one would be the velocity of the wave. The velocity of the wave depends on the medium. It only depends on the medium. We will see all these terms one by one. Don't worry. Then, if it is a progressive wave, energy will be transported along with the energy and momentum will be transported, but there will not be any transfer of the particles of the medium. Do we understand this? Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to note it down, everyone.
Sir, could you please explain third point once?
Particles move like this, simple harmonically, that's it. Nothing else. Wave goes, particle just moves like this. Particle don't go
Sir,
anywhere.
the last sentence, they do leave their position and move with the disturbance.
Which one?
Third point, sir. Same third point. Uh,
They
they
do
vibrate
not.
simple harmonically about their position. They do leave.
I mean, they leave their position because they are oscillating. So they do leave their
And
position.
move with the
They
disturbance.
take it out. Just remember that they are oscillating simple harmonic. Okay? Just remember that. Got it? Now note it down. You understand everything? Just take that point off. Because in some cases, longitudinal wave, they move along the disturbance. Sometimes they are moving opposite to the disturbance. So don't confuse it now. I'll give you 2 minutes to note it down. Now, we have seen the characteristics of wave motion. Now, let us first go through, I think we need to go through the classification a bit more because I think there are some confusions there. So, we will just go through the classification and see the different types of wave before we end up this class. So, the next class we can start with the terms. Now, based on the classification, we had seen that the waves can be classified based on the medium, right? Yes or no?
Yes, sir.
Based on the medium, you can classify waves. And what is the first type of wave classified on the basis of medium? You can call them as EM waves, or you can call them non-mechanical waves. Now, this EM waves and non-mechanical waves, I think we will do at the end. At the end of the course, whenever we finish it, we will do it at the end of the course. The first one is EM waves or non-mechanical waves. Now, what are the things that you must remember about this EM waves or the non-mechanical waves? Yes, they do not require what?
Medium.
Yes, they do not require medium for their transportation. Do not require medium. There is no medium required for such waves. Now, why they are known as EM waves? They are known
They
as
have both electric wave and magnetic wave.
they have both electric and magnetic fields, and those electric and magnetic fields are changing simple harmonically, and they are perpendicular to each other. They are also perpendicular to the direction of propagation of waves, and therefore these waves are known as EM waves. Do we understand this? Yes or no?
Yes, sir.
Now, whenever we talk about an EM wave in vacuum always travels with the velocity of light. Do we understand this? Yes or no?
Yes, sir.
This EM waves, and we will see this term. We have seen the term polarization. No, we have not seen it. We will see in the chapter on optics that they can be polarized. Talking about their nature, they are transverse in nature because everything is oscillating perpendicularly. So you can call them as transverse in nature. This EM waves, any wave will have energy and it will have momentum. They travel in straight lines with the speed of light. Do we understand this? Now, is this EM wave or non-mechanical waves clear to all? Yes or no? No or yes? You understand this, everyone?
Yes, sir.
I'll give you 2 minutes to note it down. Do it fast. Then, then we move on to the second type of wave, which is known as mechanical wave. What is the first thing
Sir,
that you
you
must?
have written non-mechanical wave.
Arey,
Non-mechanical
yaar.
oscillation.
Now it is a mechanical. The first thing that you must remember is they require what?
Medium.
Mechanical. So they require medium. Medium is essential for such types of waves. Medium is essential. Medium is essential for such waves. Do we understand this? Yes or no? No, yes. They are also called as elastic waves. Why I'm giving you this name, so that we can relate them. Now, in this case, mechanical waves, disturbance will propagate with definite velocity, that is known as the velocity of the wave, which is different from the particle velocity, because particle velocity for different particles are different. Do we understand this, or this is going above what it's saying? Bye bye.
Understood, sir.
Uh, energy and momentum will propagate, but there will not be any transfer of matter. I keep on insisting there is no transfer of matter, because that is the essence of wave. If there is a transfer of matter, then it does not remain a wave, it becomes a particle. Do we understand this, or it is going above what it's saying? Bye bye.
Understood, sir.
uh, Now, what for this wave to propagate, the medium needs certain properties, and we will see those properties point by point. But the propagation of this wave is possible only because of properties: elasticity, inertia. I will give you a list also what are the properties required for the medium to have this propagation of wave. Properties required. Have you noted down up till here? Yes or no? No, yes.
Yes, sir.
Huh? What are the properties required? Number one, elasticity. The medium should have elasticity. If the medium does not have elasticity, then what will have? A jing 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 jing. The particle have to oscillate. If the medium does not have elasticity, when the particle goes up, it will not come down. Do we understand this? So the medium must have elasticity. Do we understand this? Elasticity. If there is
Yes,
a
sir.
inelastic medium, wave cannot move in that medium. Mechanical waves we are talking about. Remember, for EM waves, we do not need medium. So these are not required for the propagation of an EM wave. We understand this, yes or no? Eh? Or this has gone above our head saying bye bye. Bye bye, sir. I'm going. Don't worry about me.
Understood, sir.
Please remember, because any of these properties, any of these things can come as a question. The second property that is required is inertia. The medium should have inertia so that it can store energy and momentum. If the medium does not have inertia, momentum and energy will not be stored, and energy will not be transferred. And the particles, once given an acceleration, boom, there is no inertia. They will just go boom, 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 and never come dum, 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 dum. Do you understand this?
Yes, sir.
Then the next point is the friction has to be minimum. If there is a lot of friction, lot of energy would be lost in overcoming that friction, and it will be of no use. The wave will be losing a lot of energy. Do we understand this? And
Yes,
then
sir.
the next point, the density should be more or less uniform, so that the energy that is carried is constant. Are we able to understand this? Yes or no? No, yes.
Yes, sir.
Or it is going above our head saying bye bye. Bye bye, bye bye. I'm going. Bye bye, bye bye. Don't worry about me. Bye bye, bye bye.
Understood, sir.
Have you noted it down? Yes or no? No, yes.
Yes, sir.
Then comes the next classification based on the propagation of energy, whether the energy is getting propagated or not. The first type of wave in this wave is known as progressive wave, or you can also call it traveling wave. The wave is traveling. What do you mean by traveling wave? Huh? The wave, the particles don't go anywhere. Remember, the disturbance and energy is traveling. Energy is getting transferred. That is what it happens in this traveling wave or the progressive wave. The progressive wave travels with a constant velocity in the medium. Do we understand it? It only depends on what medium are there. If it is a solid medium, velocity will be different. If it's a liquid medium, velocity will be different. If it's a gaseous medium, the velocity will be different. Do we understand this? Yes or no?
Yes, sir.
Then the second type of wave will be known as standing wave, khadi hui wave, standing wave, or you can call it stationary wave. We will do a detailed discussion on these waves. Don't worry. Remember, even in the standing wave, khada hua wave, stationary wave, the particles are also oscillating. Standing wave does not mean that the particle also remain in their mean position like this. No, the particles are oscillating, but energy is not getting transferred. Do you understand this? Or just gone
Yes,
above
sir.
it saying bye bye, bye bye, I'm going, bye bye, I'm going, bye bye, I'm going.
Understood, sir.
Hmm. Have we noted it down?
Yes, sir.
Then the third classification comes based on the what? Direction of propagation. In how many direction it is propagating. Propagating means energy getting transferred. So the wave could be one dimensional. Energy is transferred only in one direction, and that is the first type of wave that we are going to study, and only type of wave. Energy wave in a string. Do you know string? You have a string and then you can create a wave in a string. We like this.
Yes, sir.
That is a one dimensional wave. Then you can have a two dimensional wave. Waves on water are two dimensional. Do we understand this? This
Yes,
simple
sir.
simple stuff. Wave on the surface of water are two dimensional. No points for guessing this one correct. Then there is a three-dimensional wave where energy is getting transferred in all the possible dimensions. There are three possible spatial dimensions: light and sound wave. When I am speaking, my words are not going only this. They are going here also. They are going here also. They are going here also. Do you understand this? Huh?
Yes, sir.
So these are the three types of waves based on how they are, in which direction they are propagating, along how many axes are they propagating, along how many dimensions are they propagating. I hope this point is pretty clear. Do we understand this? Yes or no? No, yes.
Understood, sir.
Have you written this down? Yes or no? No, yes. Huh?
1 minute, sir.
1 minute, sir. Why 1 minute, sir? Good for bacha.
Done, sir.
Everyone, sir?
Yes, sir.
Then there is the last classification base, and this classification is based on how the particles of the medium are moving. Now, particles will only move when there is a mechanical wave. So this type of classification is basically for mechanical waves, transverse wave and longitudinal wave. What happens in transverse wave? As you can see, the direction of propagation of wave is like this. Do we see this? Jig, 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 jig. And the particles are oscillating perpendicular to it. These type of waves are known as which waves? Huh?
Transverse waves.
And these are known as your longitudinal waves when the particles of the medium oscillate in a direction which is parallel to the direction of propagation of wave. Then that wave becomes longitudinal. Do we understand this?
Yes, sir.
So in transverse wave, particles are oscillating in the direction perpendicular to the direction. In longitudinal waves, they are oscillating in the same direction. I hope everyone understand this. Yes or no? No, yes.
Yes, sir.
I'll give you 2 minutes to note this down. So in transverse wave, particle of the medium oscillate. Remember, the oscillation are simple harmonic in nature. Do we understand this? Simple harmonically about their mean position, but they oscillate perpendicular to the direction of wave propagation. Do we understand this? Yes or no?
Yes, sir.
Then these waves travel in the form of crest and trough. Do you understand crest and trough?
Yes, sir.
Crest and trough. Right. What is crest? What is trough? I will show you the diagram as well. Don't worry. What is a crest? What is a trough? A crest is a portion of the medium which is above the mean position. Yes or no? Or the normal position
Yes, sir.
or maximum position, that is the crest. When they are above their mean positions or normal position, that is known as the crest. Everyone knows this? Yes or no? No, yes.
Yes, sir.
Then what is the trough? Here the particles of the medium are below the normal positions. Do we understand this? Or it has gone above
Yes,
our
sir.
head saying bye bye, bye bye, sir, I'm going bye bye. And this is a diagram of a crest or a trough. We can see this diagram, yes or no?
Yes, sir.
Crest, trough, crest, trough. If I just draw this as the normal level, this is the normal level, and you can see the crest and the trough going like this. Do you understand this? Yes or no? Crest, trough, crest, trough. Yes or no?
Yes, sir.
You don't have to write a definition of crest. You just draw it. No one is going to ask you a definition of crest. I hope you understand this. Yes or no?
Yes, sir.
So let's move ahead. Yes or no? You just draw the diagram of crest and trough.
Yes, sir.
That's it. You don't have to write everything, beta. I hope you understand it. Then what are the examples? You don't have to write. No one is going to ask you example. You have played with the guitar, waves in a guitar, sitar, violin. All these are examples of transverse wave, wave in solids. Now, one thing that is more important to understand is that these transverse waves can be easily formed in solids, but it becomes very difficult in liquids. You have to make a setup for that transverse wave to happen in liquids, and in gases it is almost impossible to create a transverse wave. So basically, whenever we talk about transverse wave, we are basically talking about solids, the waves which are in solids, wave in a string, wave in a rod. Those will be the examples coming in the case of a transverse wave. Do we understand this?
Yes, sir.
Those will be the example coming for this transverse wave and nothing else, because it is very difficult for us to set them up in liquids and solid. But wave on the surface of water can be taken as a transfer wave. That is the only example that is. You don't have to draw everything. This is just for your understanding that I am telling you. Don't just write to everything. This understand it. This is transverse wave in a rod. If you have a rod and you clamp the rod and hammer it, the waves will be set up in the rod. Do you understand this? Waves in water, waves on a string. These are examples of transverse wave. You don't have to write everything. Understand? The only thing I'm seeing is you writing. Don't write. You don't have to understand. Don't write everything. No one is going to ask you wave in. This question will not come. What type of wave is wave in water? That will come only in NEET. Okay, just understand it. Write it in very short. Transfer wave example, wave in water, this, so that you can understand them. Don't have to topify everything. Some things I'm just telling you to understand. Did you understand transverse wave? Have you written about transverse wave?
Yes, sir.
Okay, then we will continue with this in the next class. I'm not sure that will be able to do this, the other wave, longitudinal wave. So we'll continue with that in the next class. Okay. So we'll continue this topic in the next class. We have dealt with transverse wave. We have seen the type of waves that are there, and we'll continue with this topic in the next class. Okay.
Yes, sir.
Everyone understood up till here? Everyone understands up till here? Yes or no?
Understood, sir.
Okay, then we'll continue this class in the next class. Bye bye. Take care. God bless you all.
Bye, sir. Have a good day.
Same to you, beta. Take care.